All right, everybody. Hello, sixth graders. It's time for that chapter 13 review. Now, you saw the little clip I put up yesterday. I went through most of this lesson only to discover that that particular video ended up not usable. I don't want to tell you how much that frustrated me. But anyhow, let's take a look at this stuff. Now, we're wrapping up this unit on statistics. And I got to thinking about that last night because generally speaking, every now and then I reference a little bit of this knowledge in my everyday life, but generally speaking, I don't really spend a great deal of time worrying about statistics. What I do know, though, is learning this stuff is just part of what we need to know. Now, we don't need to absolutely be able to do all this statistical work. And on an everyday basis, we hardly ever have to use it. In sixth grade, what you're doing is you're familiarizing yourself with it. You're being introduced to it so that you begin to gain some understanding of it. Because later on in your life, when you get to college, when you get out in the workforce, you actually may be called upon to do this on a daily basis. I mean, there are people out there that make their living just doing statistical work. So, being able to memorize all this stuff, and actually, I think that's just one of the failings of education in general, is the fact that we force so much stuff into kids, force them to memorize these things. And, there is some truth that some of this stuff you'll never use ever in your lifetime. But, part of understanding and being educated enough to recognize what these things are. So that's really all we're trying to do, is we're trying to give you some understanding of it. Now, as you work through this unit review test, work on the problems. If you don't get it, work at trying to get it. Because the more of it that you do get, the more knowledge you'll have, the better understanding of it you'll have, and it will have some value to you in your life. So let's get started. On page 757, the first thing there is a dot plot. And if you can look in your books, which I hope you're doing, on 757, that dot plot is just one of the ways that we can look at understanding some data. And it asks you 4 questions about the dot plot. The first one is, are there 2 peaks? And if you're looking at the dot plot, you can clearly see that there is a peak that occurs at 5 and a peak that occurs at 11. Now these are chin-ups, the amount of chin-ups a person can do at one time. So anyhow, there's those 2 peaks that show up in that data set. 1B there says there are no clusters. And it's asking you whether that's true or false. And the truth of the matter is there are clearly 2 clusters in that data set. There's a cluster between 3 and 5 and a cluster between 9 and 11. Now the next one asks you whether there's a gap between 6 and 8. And there's no data recorded between 6 and 8. And so there's clearly a gap in that data. It goes on that most chin-ups that anyone did was 15. And if you look at the dot plot, you see there's one person who could do 15 pull-ups. So that's true. And 1E, it says the modes are 3, 4, and 9. I would say yes to that. Because 2 people in 3, 4, and 9 represent the most amount doing the same thing. You could also look at it and say that, well, really the modes would be 5 and 11, because that's the most people doing the most amount of chin-ups. So on that one, your rationale, depending on how you look at it, I'd be willing to accept either one of those answers if you could support it with your argument. Number 2 is a histogram. And we know that a histogram is a graph that shows groupings of data. And this one is showing high temperatures in Fahrenheit degrees of various cities in one day in March. And if you look at that histogram there, it's asking you to understand 2 different things about it. And it's saying, select the best word to complete each sentence. And the sentence is, the histogram has 0, 1, or 2 peaks. And that histogram really clearly only has 1 peak. And that peak occurs between 41 and 50 degrees Fahrenheit. It goes on to ask, the histogram has or does not have symmetry. Remember we talked about symmetry? Symmetry is the shape of something that if you drew a line in it and fold it in half, it would be symmetrical. And when you look at this histogram, you see that it rises and falls in a very kind of ordered fashion. So yes, it does have symmetry. Now we're not going to do every problem in here because I want you to actually take on some of these problems and solve them yourself. Practice some of these skills because if nothing else, the skill itself is engaging your ability to work through and solve a problem, which is a really important characteristic to have, because if you can solve problems, people are going to want to hire you. Looking on page 758, we have a data set there that shows the scores of players on a winning team of a basketball game. And it's asking you to solve out of that data group the median, the lower quartile, and the upper quartile. So why don't we go ahead and do that one and see if we can answer those questions. Now the first thing you got to do whenever you're trying to figure something like this out is you got to organize the data, and we do that in a fashion from the least to the greatest. So let's line up our data. And I see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pieces of data in this chart. So looking at the smallest amount, we have 0, 0. Remember, you got to list every one of them. So there's 2 zeros, and I see 2 1s. The next would be a 4. We got a 4, we got a 5, we got a 6. So 4, 5, 6. The next value would be 9, and there's 1 9, and then it goes to 13 and 17. From there it goes to 22, 30, and 47. Well, that's a pretty big range of data. And what would the range be? The range would be subtract the largest value from the smallest value. And in this case, smallest value is 0. And 0 from 47 means this range is 47. It's not asking for the range, however, but just in case. So now we're looking for the median. Remember, the median is that number right in the middle of the data set. And fortunately, there are an odd number of data points here, so we can go right to the middle of this, and we can determine that our median is 6. So that answers the first question. What is the median? Now it wants to know what the lower quartile and the upper quartile are. So, as we work to figure that out, remember that working from our median in either direction, this being the lower quartile, this being the upper quartile, then we can determine what those values are. And how do we do that? We do that by taking those values and finding the middle number. Now there are 6 on either side, so they're even. So that means you got to take the 2 in the center. You got to add those together and then average them. So this is 2, and that's going to be divided by 2. And this is 39, and it's going to be divided by 2. So this is going to equal 1, and this is going to equal 19.5. Are you all with me on that? So we took those 6 numbers, we found the 2 in the middle, added them together, divided it by 2, and that gives us our upper and lower quartile. So our lower quartile is 1, our upper quartile is 19.5. So that answers that question. All right, what else we got here? Like I said, I'm not going to do all these problems. I'm going to let you work through some of them. But let's look at number 4. What's interesting about number 4 is it gives you a box plot there. It gives you a line, a number line, and a box plot, and it gives you A, B, C, D, and E, but it doesn't give you any values. But then it wants you to figure out what the values are. And you can do that. I'll show you how. So first thing we want to do is we want to take our data set for number 4. And in number 4, there are 12 numbers there. So let's get those arranged from the least to the greatest. And the smallest number I see there is 17. And I see that number there twice. So we got 17 twice. Then the next number up is 18. Ooh, wait a minute. I actually see a number 16 over there on the far right. So we do have a 16. 16, 2 17s. Looks like 1 18. Next number up is going to be 19. And I only see 1 19. Then 20, and I see 2 20s. And then 21, I see 1, 2, 3 21s. After 21 is 22. There's 122. And it looks like we finish off with a 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's always smart to count. Make sure you got them all. Because if you miss one number, changes everything. All right, so there's our data. Now, we've got this box plot here. And we've got a variety of points on this box plot. And this is A, B, C, D, and E. And it wants us to fill in the blanks. Now, how are we going to do that? Well, first thing is you have to recognize what these points are. The point on the far left and the point on the far right, that's the least value. That's the greatest value. So if that's the least value and the greatest value, point A is going to be 16. Point E is going to be 24. All right, that was easy. I don't know if you can see those numbers. Let me darken them up here a little bit. 16, 24. Now we've got 3 dots in the middle here. What do they represent in this box plot? Well, this is the median. This is the lower quartile, and this is the upper quartile. So now how do we find those? Well, you know how to do that. Our median, we need to find the middle number. And because there's an even amount of numbers, we got to take the 2 center numbers, add those together, and divide it by 2. So that's 20 plus 20 is 40 divided by 2. That means 20. This dot here, the median, is 20. Now, we've got to draw our number line. I don't know why this is so hard to see today. Must just be, well, that certainly isn't a very good marker. I think the way the light is reflecting off the board today is making it difficult to see. So anyhow, there's our number line. And that number line is going to go from 16 to 24. So let's start here at 16. This end of it's going to be 24. You can take it one step beyond if you want to. Doesn't matter. You can actually start at 15 and go to 25. That way we know our numbers are all inclusive. All right, so let's put in 17, 18, 19, 20, 21, 22, 23, 24. Like so. Now we've got our number line with all of our values. So let's define our median. We know where that's at, right? Our median is 20, right here. So now we got to figure the lower quartile and the upper quartile. And again, you're going to go left and right of your median, and you're going to figure out the median of the values in either direction. And we're moving from our low point of 16, our high point of 24. So those are the only numbers that matter. We don't need to take that into account. We don't need to take that into account. Just what we're being asked to discover here. All right, so now left of 20, we've got 16, 17, 18, and 19. So that's 4 numbers, which means we got to take these 2 numbers, add them together. 17 and 18 is 35, and divide that by 2. And then on the other side here, we've got 4 numbers again, 21, 22, 23, and 24. So we'll take these 2 numbers, add them together, which is 45, and divide that by 2. So half of 35 is 17.5. And half of 45 is 22.5. Are you with me? So we found these 2 points. Our lower quartile is 17.5, and our upper quartile is 22.5. Work it. You'll get it. All right, what's the next problem? I'll let you guys work number 5 on your own. Let's go to number 6. The data set shown is the numbers of glasses of water that Dahlia drinks each day for a week. So, 1, 2, 3, there's 7 data points there. So let's line them up. The least is 6. So that's where we're going to start. 6. Then we've got 2 7s. We got 2 7s, 1 8, and 2 9s, and 10. 1, 2, 3, 7 numbers. All right, now what they're asking a party is, what is the mean number of glasses? Now, we've been talking about median. Now we're talking about mean. It's a different thing. A mean is the average. So we're going to add those all together and divide it by 7. There are 7 data points. So 6, 7 is 13, and 7 is 20, 28, 37, 46. This equals 56. We're going to divide that by 7. So we know that our mean is 8. Got it? Okay. Now, let's go ahead and create our number line. And we're going to start at 6, 7, 8, 9, 10. That's pretty much all we need to do here. Because the next part of this question is asking us, it's asking us for the mean absolute deviation. And the mean absolute deviation is the number of places between the mean and the numbers of the data set. So let's go ahead and do this. We know that our mean is 8, right here. So let's go ahead. We've got 1 6, we've got 2 7s, we've got 1 8, we've got 2 9s, and 1 10. Now, 8 is our mean, so now we're going to count the distance. So the distance to 6 from 8, now you're going to have to follow along here, is 2. The distance from 8 to 7 is 1, and then from 8 to 7 again is another 1, and then from 8 to 8 is 0. It's right there at 8. From 8 to 9 is 1, from 8 to 9 again is 1, and from 8 to 10 is 2. So now we've lined up all the distances. We're going to add those all together. 2 plus 1 is 3, 4, 5, 6. So this will equal 8. And then we count the number 1, 2, 3, 4, 5, 6, 7, and divide that 8 by 7. So let's do the math. 8 divided by 7. 7 goes into 8 once. Are you with me? Now, to continue this division, we're going to place a decimal point. We're going to add a 0 and bring the 0 down. 7 goes into 10 once. So here's our 7. Subtract that. And that gives us 3. We're going to add another 0. Bring that 0 down. 7 goes into 30 4 times. 4 times 7 is 28. Now, that's probably all the further you need to take it, because this is not something you're going to solve as you keep going. You're going to end up with a big long decimal. So you can stop at 1 and 2 decimal places, 1.14. So the absolute deviation would be 1.14. That's as far as I'm going to go today. Tomorrow we'll get into some of the graphs that you see in the remaining, but go ahead and work ahead if you feel confident that you can solve those problems. If not, tune in tomorrow and we'll work through a couple of those problems to help you better understand it. Meanwhile, it's Wednesday. We're almost done with this math book. Hang in there, kids. Take care of yourselves. Stay safe. Do your part. Be kind to people. We'll see you tomorrow.